Hello everyone, this is Dr. Ali, and in this session we want to dive into recursion functions and the concepts comes with it. For starters, we know there are different functions in Python: user-defined, built-in, lambda, and recursion. Well, we don't get into these functions. These are very simple, and even their names are descriptive enough for you to understand what are these about. We want to focus on recursion functions. All right, so let us see what is recursion. Recursion is this technique for solving computational program or problem by repeatedly applying the same procedure to reduce its successively smaller problem. So what we understand from this line is whenever we want to solve a big problem, and we want to break it down into a smaller problem, and then by solving those smaller problems, we can backtrace to solve that big problem that we started with. So that is the goal for recursion. Recursion refers to a programming techniques in which function calls itself either directly or indirectly. That is why we call it recursion, right? A function is calling itself within itself. So that is actually a recursion of the recursion programs or that actually come into two different type, direct and indirect, that we will see a little bit what are the difference between direct and indirect. Recursion is a common mathematical and programming concept, and recursion has two parts: one or more base cases and a recursive steps. So basically, these are very important. For every recursion function, we need to find out what are these two. What is the base case, or what are the base cases, and what are the recursive or recursion steps. So base case, so if I want to just give you a, let me see if we have anything here. So base case is a very special case of our problem statement that we want to attack, which we already know the answer for that base case for that specific problem that we want to solve. So in another word, in recursion, we break down a big problem into smaller and smaller problems till we reach the base case, and then we use the base case to backtrace and find out the result for that smaller problems in order to find out about the answer or the solution for that big problem that we started with. So like I said, there are two versions of or two type of recursion: direct and indirect. Very simple. Direct, we call the same function within the same function in the function. So recur here is called inside this recur. So this is direct. Indirect is when we have two functions that each one call the other one. So look at here. Recur A is calling recur B, and when it comes to recur B, it calls recur A. So that's how recursion is called here in this example. But in this series of videos, we just focus on direct. But the idea and the concepts are exactly the same. So the very famous example of this recursion function is factorial. What is factorial? Factorial is defined as this: that n factorial is equal n times n minus 1 factorial. For example, 4 factorial is 4 times 3 factorial. 3 factorial is 3 times 2 factorial. 2 factorial is 2 times 1, and we know that the 1 factorial is 1. So another way to explain it is 4 factorial or n factorial is all the multiplication of all the numbers or all the positive number which are smaller or equal than the number that we want to find a factorial about. So if we want to find a factorial of 4, it means multiplying the numbers from 1 all the way up to 4. Okay, And we know that there is no, we don't have any negative factorial for negative numbers, and factorial of 0 is 1, and factorial of 1 is 1. So these are the base case, basically. So let's see if we want to solve this, how we can do it. So there is one easy way to solve, and it, of course, is using the just one simple loop functions or a loop iteration in order to just time multiply from starting from 1 to all the way to the number that we want to return for the factorial. But we want to solve it with recursion. First, we need to know what is the base case. We already defined the base case. If there is a number is 1 or 0, we return 1 because we know that 1 factorial is 1 and 0 factorial is 1 as well. So this is a base case, basically line 2 and 3. But what is the recursive part? Basically is here that n times factorial of n minus 1. This is the base, or this is the recursive part. And if you notice here, the number now is n minus 1. So that is important. When we're dealing with the recursive or recursion function, when we call the function within the function, we need to lower the data space. So here we call it with n, but we recall back with n minus 1. So this will happen, keep happening. So when I'm calling this with n minus 1, it comes here, it calls the same function with n minus 2. This will happen all the way till we reach to the base case. So you should make sure that whenever you write in a recursion function, it has to reach to the base case. So if that you develop something or some recursion function that's not the case that we reach to the base case, definitely you did something wrong. You need to correct your code. So let's look closely. If this is a recursion function for factorial, what's really happening under the hood? Imagine we want to find the factorial of num 4. Basically 4 factorial. We want to see what is the 4 factorial. So we call this function f with parameter 4 at the beginning. And then it comes here, it says 4 is equal 1, no. And it call 4 times and call the function factorial with parameter 3. Parameter 3, it says 3 equal 1, no. So what will happen? In order to obtain this value for factorial 3, we need to know what is value for factorial 2 based on this equation. And then factorial 1, because factorial 2 call factorial 1. And this is, I showed it with 2 circles here, because this is actually the base case. We know what is the factorial of 1 here in this base case, line 2 and 3. So the result of this we know is 1. So if we know this, then we can trace back all this graph that we formed. So we know that then what is factorial of 2, because 2 times 1 was equal factorial 2. Factorial 2, if we know factorial 2 is 2, then we know factorial of 3 is 3 times 2. And if we know the factorial of 3, 4 times factorial of 3, which is 6, 4 times 6 is 24, is the result for factorial 4. So this is the result for factorial 4. Let me actually run the program, and then you see as well that that is the result that we get for factorial 4. So this is the code. This is the same thing, but I only added these print statements here in order to just be able to see this graph that we have here. So let me run this. So you see, it says factorial 4 is the one that we wanted to calculate. Factorial 4 went to call factorial 3. Factorial 3 went to call factorial 2, factorial 1. This is the base case. And now we are in the traceback. You're basically here now. You'll see this print statement. And so far, these print statements was because of this line. Now, these print statements are because of this line. Factorial of 2 equal 2. We are in the traceback. Factorial of 2 equal 2. So basically 2 times 1 is 2. And then factorial of 3 is 6. 3 times 2 is 6. We have it here. And then factorial of 4 is 24. And then we print this last statement to see the 24 of the result. That is for today. If you have any comment, concern, please leave it down below. And stay tuned for the next sessions that I will solve different recursion out problems. Have a great day, everyone.